We have all heard temperature being used in our everyday lives. The temperature outside, your house thermostat, and even the temperature of our food. Temperature can be specifically described in number values such as Celsius and Fahrenheit, but it can also be generally described with our words, like that's way too hot, or like that's really freezing. Temperature can be described on a thermometer. A thermometer generally has a red fluid inside and then numbered lines along its sides. We can read a thermometer by looking at where the red liquid inside stops on a line, and that is the approximate temperature. Why is temperature important? Well, when we heat something up or cool it off, it can change its state, like solids, liquids, and gases. For instance, let's think about water. When water is boiled at 100 degrees Celsius, it turns into a gas or a vapor. When water is frozen at 0 degrees Celsius and below, then it becomes ice in the form of a solid. And any other temperature between 0 and 100 degrees Celsius, water is a liquid. By knowing that temperature has a strong impact on how substances exist, then it is important for us to know how to handle extreme temperatures carefully. For example, always wearing oven mitts when touching a plate or pot that is hot from cooking, as to not burn ourselves. Or, when it's really cold outside, we need to wear proper warm clothing so we don't get frostbite and freeze our skin. This includes mittens, hats, boots, etc. Warm clothing for outside protects us by acting as an insulator, meaning that it keeps our body heat inside the clothing and makes sure we don't lose all our heat to the cold surroundings. But how do animals stay warm in the winter? Well, they have fur or feathers and even a layer of fat. All of these act to keep the animals' bodies' heat inside their bodies, which keeps them warm and alive all winter long. So, we have learned that temperature is a very influential part of our lives, meaning that we need to control the temperature inside buildings so that we are at a comfortable temperature at home, at school, and any other buildings you can think of. But how do we do this? Well, you have probably seen the thermostat on the walls of buildings, which is the control panel that changes how warm or cold someone wants the building. When someone turns the thermostat up by a degree, that means the building is supposed to be warmer than it already is. So the heating system in the building will kick in and either pump warm air through the building or hot water through the pipes of the building to heat up the building. This process works because warmer air moves to cold air spaces, warming the air up until the building is heated to the set temperature on the thermostat. However, this process requires energy. In North America, we mostly use a process in which cold air is brought into a chamber where natural gas is burning as an energy source, and that cold air is heated up in a chamber and dispersed throughout the building as warm air to heat it up.
Hi, I'm Shab from People of Science, and today I'm going to show you the power of cold and hot temperatures in relation to air pressure. The experiment we're going to do today is called the crushing cans experiment. And before we get into the science and demonstration, know that all you need for this is a heating source of some kind. That could be your oven, it could be a heating stove, some aluminum bottles that are empty, and cold water. First thing you're going to want to do is get an empty pop can, and the bigger it is, the bigger the implosion is going to be. Now, to start off, you're going to want to put in roughly a tablespoon or 2 tablespoons of water into the can, and make sure it's empty beforehand. Then what you're going to do is you're going to place it on the stove. Now, make sure if you're concerned with safety, get an adult to help you with this. So once it's on the stove, you're going to turn it on to max, and you're going to let it boil, let the water inside boil. You'll be able to tell by the sound and also from the smoke coming from the can itself. Once the water inside is starting to boil, you're going to grab it with a pair of tongs, and you're going to grab it from the bottom. Make sure you do it very quickly, and you're going to actually immerse it into the cold water, and that'll make the can implode. And we'll get into the science why after we watch this demonstration here. So let's do this now. So I'm going to grab this, and then very quickly put it down there in the water. And look at that. So you're going to notice that the can just imploded almost instantly. So what happened here? Well, when we initially put in the water at the beginning of the experiment into the cans, the water started to boil on the stove. And what ended up happening there is that water became vapor pressure, right? It became vapor. And so it started to push out the air molecules inside the can. And so after heating the can up and getting that vapor pressure in the can high, we inverted it and cooled it down very quickly. And what resulted from that cooling was that the vapor molecules inside the can very quickly condensed. And so that created a partial vacuum inside the can itself. And this partial vacuum inside the can is what caused it to implode in on itself. So let's try this again with the science in mind now. So I'm going to grab this very carefully and quickly submerge it into the water. And look at that. Power of air pressure and hot and cold temperatures. So thanks again for watching another People of Science video. For more science-related content, check out our website at peopleofscience.net.